Good afternoon, and thank you for joining us for our Beyond Hyperconverged webinar, introducing our product Cloudistics Ignite to the UK. My name is Chris Hurst, and I'm responsible for the Cloudistics business in EMEA. We're delighted to present the vision, technology, and benefits of our super converged enterprise cloud platform, and to show you the simplicity of our single management portal. Our Executive Director of Pre-Sales and Solution Architecture, Carmelo McCutcheon, will present the Ignite solution, followed by a 15-minute Q&A session run by Tessa Hussain. We would really encourage and appreciate all questions and feedback in the Q&A. We have a prize for your participation today. In order to win the DB Power Predator FPV quadcopter drone with an HD camera, please fill out the survey at the end of this webinar. The survey will launch at the end of the webinar, so please keep the session open until you see the survey appear. We also encourage you to tweet @Cloudistics with a hashtag BeyondHCI. The winner will be the individual who completes the survey and tweets the most, and will be announced at the beginning of next week by email. I'm now going to hand it over to Carmelo to present the vision, technology, and benefits of Cloudistics Ignite. Thanks again for joining.
And thank you guys for joining. And with that, now let's talk about the data center today and kind of the data center of yesterday. And then we'll talk about where we're trying to go. So today, or really yesterday, but in larger environments this still exists and is very prevalent, you had the concept of distributed systems. It was the first real scale out of the x86 platforms in the data center. We had a lot of big vendors like IBM, EMC, Sun, HP, Cisco, Dell, NetApp. They all were a piece of whatever the solution was within the environment. And then VMware came out. And when VMware hit the street in the distributed systems world, it would cost about $5,000 a virtual machine to run in an environment like that, which was still a lot cheaper than spending $50,000 or $60,000, which was really unique because essentially EMC, VMware, and Cisco got together and they said, what are the most popular things people do around virtualization in the data center? And can we make it easier and save time? Right? Because time is the equivalent of money when it comes to these deployments. So you saw converged infrastructure hit the street, and that was essentially, let's pre-cable, rack, stack, and pre-install a certain amount of the software before it gets into the customer's environment to shorten the timeline from 9 months or 12 months to 4 months or 6 months, depending on what the application rollout was. And then from there, we saw everybody else come out with similar solutions. And then in 2012, we had this huge change. I mean, it was very disruptive, and that was Nutanix, which really meant hyperconverged. And what they did is they combined storage and compute, and they made it a lot easier to install. So instead of cutting your timeline down, by 40 or 50%, now you were having 30 to 90-day deployment cycles based off of hyperconverged because they simplified storage management within the server, which is really, really unique and really, really changing the way that people implement and deploy applications today. But in the data center, hyperconverged doesn't make a lot of sense because storage and compute do not scale together in the data center for larger implementations. They scale differently. And the last thing you want is stranded resources. So here at Cloudistics, we really believe in the super converged infrastructure. And what's super converged for us and why we fall into this category is because we believe that convergence is the way, but we don't believe storage and compute in the same unit is the right way. We really believe that the network is where you should start. You should truly converge everything on top of the right network and do it the right way. Because no matter what you do with storage, compute, and applications, if your network isn't deployed correctly, nothing will work right. So that's where we started. And that's where most of our IP originally came from when we started in 2013. So when you think about what does that mean, right? What does super converged really mean? So I'm going to start with the concept first before we get into the technology. So when you look at a traditional environment, whether you're doing hyperconverged or converged infrastructure, you're still distributed because most of the largest enterprises, they have so much, they have to be distributed. They can't even be CI. and they only use CI architectures for new applications because the old stuff has been there so long, you just can't change it. You just got to wait for it to go away, kind of like the mainframe. And I know some people that are still waiting for that one to go away, and it hasn't happened. So we'll see what comes over the years. So with that, sometimes the hardest thing to do is to get everybody in the same place and make decisions on what you're going to deploy. Pick one architecture that makes sense. Because everybody has input, and you have to evaluate all these decision makers, stakeholders, and opinion holders within your organization to really create what is the right architecture for the applications you're going to deploy that really support your customer base, right, and help you guys make money, which keeps us all employed. So once you get through that, then you have to figure out, is it integrated, is it validated? I got to do some type of proof of concept on a small scale. I got to test it. I got to get acceptance. We got to make sure the applications run at that small scale. And then from there, I got to figure out, what do I got to do to go into production? How much more do I have to add? What changes in the implementation when I tested it for 200 or 500 users when I want to go to thousands of users or even beyond that? And then you have to turn around and redeploy the whole thing. You got to wipe it, you got to re-architect it, and you have to redeploy it. It's really, really complicated. And now you got to create these run books so you can hand it over to your O&M team so they can manage it. And you got to train your O&M team on all these different pieces and parts you've integrated together, which really means that you're always going to be a part of that O&M team. You are their level 3 support. So when you think about what Super Converged really means from a concept perspective, is I want one integrated platform that I can go to this single vendor from and say, I have a requirement of X, help me design it. And once it's designed, I can start my POC. I can go through the same testing and acceptance and validation and make sure it works. But what's different about Super Converged is that when I started in the POC, now all I have to do, because I've been monitoring and maintaining the health of that application through the proof of concept, is hot plug resources, whether they're virtual resources, CPU, memory, storage, or they're physical resources being blades, storage, and network. Why everything's still running, and I can grow that environment into production. And because a Super Converged platform has a single pane of glass for hardware and software in the same team, when I transition the environment to the O&M team, I go from this 50, 60, 100-page run book that has 5 different consoles in it, 3 different CLIs, all kinds of different ways to deal with different problems, to one that's maybe 10 or 15 pages, and it's focused on the single pane of glass on how to manage the health and, I guess, the scale of the applications that you've deployed on it. So hopefully this makes a lot of sense, and the concept of Super Converged really means it's finally easy. We've been waiting for a software-defined data center. We've been waiting for a single platform. I've been waiting for 20 years. It's finally here, which is awesome. So when you think about that, in IT environments today, you do get agility, but you only get it in certain parts of the data center, right? Adding servers is usually pretty easy, but adding storage, servers, and network together gets very hard. And then if you got to think about firewalls, load balancers, your shared storage environment, whatever you're doing for backup, and if you have dedupe included, if you have SSD arrays, if you have storage caching engines like Fusion IO with Ion, things can be very complicated. They work. Applications work well in environments like this, but they're very hard to maintain, and they take a lot of knowledge and a lot of expertise. So when you think about what Super Converged means for us, is I want simplicity and agility in all the layers of my cake. What I mean by that for us is that we started with the network. I mentioned that earlier. So we have our adaptive overlay network, which is AON. And with AON, you get network virtualization in layer 3 on the switch instead of in software through encapsulation. And then we created our hypervisor, the adaptive operating system, which is KVM, and we've tightly integrated it into AON. And lastly, we've added our Elastic Block Flash, which is an all-flash storage appliance that grows through federation. So when you think about all 3 things, the first thing we did to make it easy to manage is we made sure everything was software-defined. So what does software-defined mean for us? Because I noticed for vendor to vendor, it means different things. For us, it means every single piece of this cake is orchestrated via an API. And what does that orchestration is our Ignite Control Portal, which is a SaaS-based portal in the cloud that's already deployed, and it makes managing and implementing your infrastructure easier today. So when you think about, what's the benefit of all that? What do I really get? So because my SaaS portal is already in the cloud, The first thing that is easy is I can now finally plug and play assets into my environment and not have to deploy a management pane or a control pane. Now all I have to do is take the serial number of my first switch from my platform when it shows up, register it. Within 15 minutes, I'm ready to go. It's amazing. That really means I need power, network, and that's it. I don't have to deploy vCenter. I don't have to integrate it into HP OpenView. I don't have to worry about ServiceNow anymore. All these things have just gotten easier. So once you do that, everything's virtualized. Our network, our storage, and our compute, and they're integrated into a single platform. So there's no plugins here, guys. We don't have any shims. We're not doing anything complicated. You don't have like a plugin running on a VM, talking to vCenter, and then it's talking to the storage engine underneath, and then you have a different plugin for your Cisco network. You have a different plugin for your server platform. It's a single integrated platform, and that's really, really unique. So what's the benefit of that? I can manage my entire infrastructure from a single pane of glass, right? And I can do it from anywhere. Because it's a SaaS-based portal in the cloud, I can get to it from my desktop, my laptop, my tablet, my phone. I will say if your phone's got a small screen, it might be a stretch. You want something like a Note or a large iPhone, but you can do it, which is really, really unique. And what can I do once I'm in that management pane? I can deploy applications in minutes, guys. I can go touch a template, right-click, say create an instance. And an instance for us is a VM or an application that's been pre-configured into that template. And I could just add storage, compute, and network requirements to it, hit create, and go. And the other cool thing about the templates, right, is when you import your existing VMDKs or VHDs from your existing environment, we do driver injection, we remove things like VMware tools, we add our own agent, and we optimize the performance of that template so it screams in our environment, right? And that guarantees that any application that you run in Ignite is performance tuned and optimized so you always get the lowest latency, the best response time, and all the IOPS you ever need. So the last thing is, you'll notice in the picture before we had separate storage, separate compute, and separate network. And what that really means is I can scale any piece of my infrastructure on demand. So if I need more storage, I add more storage. If I need more compute, I add more compute. If I've added one of those that forces me to add more network, I can add more network. It really gives you that flexibility you need in the data center. So you can scale things independently and essentially manage your infrastructure to the application instead of having the, actually I said that wrong, I'm sorry guys. You can manage your application to the infrastructure instead of deploying applications on infrastructure that the infrastructure decides how you deploy it. You really can optimize everything from the application forward instead of the infrastructure forward. That's very, very unique. So now let's take a deeper dive into what the Ignite platform really means and what I mean by virtualized everything. So I'm going to start with AON, our Adaptive Overlay Network. And there are a couple of key things or key takeaways you want to have when you think about this platform. The first thing is layer 3 network virtualization in the switch. What does that mean for us? That means we don't do encapsulation. And when you do encapsulation, you take an existing packet, you put it in a bigger packet, and then you send these larger packets, or you have to send multiple packets through your network, which creates more latency, more CPU load, and just slows down everything, right? So we do that in the switch, and a packet is a packet, and we do it at wire speed without creating any latency. So you don't know you're virtualized. And we do that in layer 3 instead of layer 2. So when you think about what happens once I virtualize the network, I get segmentation, or what everybody calls microsegmentation, where I can create a virtual network that I attach VMs to that don't know about anything else but the VMs that live on that virtual network. And then the last thing we did, we want to make sure you understand that you will not have a performance penalty for virtualizing your network, which is the #1 reason why people aren't doing this as quickly as they would storage or server. Because virtualizing the network, #1, with other people is hard, and it does create latency if you don't do it right. And with us, we use a non-blocking, low-latency switch architecture. We do everything in hardware. It really makes things faster and easier. So the next thing I want to talk about is our adaptive operating system. I said it earlier, I'll say it again. It's a KVM-based hypervisor. It runs x86 workloads. So you can run anything x86 on here. CentOS, RHEL, Ubuntu, Windows, Hortonworks, Cloudera, Spunk, you name it, it'll run here. The next thing that we did after supporting all those x86 traditional VM workloads is we looked into the future, right? Everybody talks about Platform 3. What does Platform 3 really mean? For us, it means the next generation of virtualized applications, which is containers. And specifically, containers for us is Docker containers. And what we do that makes us unique and different from everybody else is that when you have a Docker container that runs in Amazon or Azure, Docker's APIs treat the infrastructure as composable. When you bring Docker on-prem today, you lose the composable capability that you have from the cloud, because now you can't just ask for a network IP address. You can't just add storage seamlessly because you've got to worry about the physical infrastructure because not everything's virtualized. The other thing is a lot of people have created plugins for Docker, but that means you've got to change your code to use a new API if you want to exploit whatever capability that plugin gave you from an infrastructure perspective. And what we're seeing, the first plugin or the first type of plugin, is the ability to solve persistent storage. But that means you got to rewrite the code. If you're running in the cloud, do you want to pull that application out and have to rewrite the code in the process and then go through a QA cycle? You probably don't. So what we do that's different is we emulate the same API that you're used to from the cloud, and we give you persistent storage and a virtualized network. So we make it so your container can move from Amazon to us without having to change the code, and you get the benefit of persistent storage. And that really is next-generation virtualization at the container level. So when you think about what's behind these capabilities or what the foundation is of this house or the first layer of the cake, it all starts with our flash storage, Elastic Block Flash. So the first thing I'll talk about is what is it physically. It's a 2U appliance with redundant controllers that are active-passive that supports up to 32 flash drives that can range from 1 terabyte to 4 terabytes. And then when you lose space or run out of space within that first 2U appliance, you can add another. And you can start with a minimum of 4 drives, go to 32 drives, and it will federate your storage into a single pool. That's so you don't have to worry about creating different pools and worrying about where VMs are and who's using what. We take care of that for you, and we make it really, really easy. And then the second thing we do, which is really, really unique to us, if you're familiar with other hypervisors and file systems that get injected at the hypervisor level or even at the storage level, they create latency. So when you think about a traditional world where you have a VMDK and you have a VM inside, his local disk is using NTFS, let's say, if it's Windows. And then it's a VMDK on top of VMFS. And then VMFS is sitting on someone's storage that's using the log structured file system or WAFL, right? So that's 3 to 4 layers of translation you got to go through, which means latency, right? Everybody that tells you they're going to do 150 to 200,000 IOPS can do it. I totally agree with them. I think the IOP problem got solved a long time ago. A long time for me is about 3 or 4 years because Flash hit the street. It's been so freaking popular. When you have flash drives, you automatically get IOPS. But the thing that people are not focused on, but I think really needs to become the new measurement of performance for storage, is latency. So by us presenting raw block runs at the VM level directly to that virtual machine with no file system in the middle, you get the lowest latent write and read from and to the storage that you can imagine. And what does that mean for us? That means 80 microseconds of latency, no matter what you're doing for a 4K, 8K type operation, from the VM down to the storage and back. That's better than 99% of most bare metal implementations on top of Fibre Channel, and we do that on top of a virtual network in a virtualized environment. Very, very unique, guys. Very, very performant, which means now you can run those storage-bound applications that have never been able to be virtualized on our platform and gain the benefits of virtualization, mobility, flexibility, ease of deployment, ease of management. And then the last thing, which is kind of, I think, the icing on this cake, is that when you have a 2U appliance and you have all 32 drives in it, we'll give you 250,000 IOPS in 2U. And on top of that, we'll give you up to around 100 terabytes usable before single instancing and thin provisioning. And then after single instancing and thin provisioning, we'll guarantee 3x the usable as your effective capacity to go with that. That means if I have about 100 terabytes of usable storage, I get 300 in the virtualized world, and I get 250,000 IOPS in 2U. And it's an active passive controller that's highly available. Very, very unique, guys. And then the last thing, and I said it earlier, but I'm going to say it again, is that we're truly software defined. So all three of these major layers in our cake are API driven. And what talks to that API? That's our Ignite Control Portal, which is a multi-site, single pane of glass that you use to manage your entire infrastructure. It's a SaaS-based portal, which we also use as a delivery mechanism for updates. And what do we mean by automatic updates? Whenever there's an update available, the portal will push it to your infrastructure locally that lives in your prem, and it'll do it in a non-disruptive fashion so you don't have to worry about things going down. So if you guys are familiar with the old days, which might even been yesterday, right, where I've got a maintenance window, it happens once every 3 or 6 months, I have to get all these customer engineers from multiple vendors in, it never goes right, I work the whole week and now I'm working the weekend and into the night of that weekend. Those days are over. We take that away. We remove it. We make things better. And then the last thing, which is really, really, really unique, I talked about multi-site. We're also multi-tenant capable. And what do I mean by multi-tenant? That means one company can buy our infrastructure and then create these things we call virtual data centers. And you could give someone a virtual data center, and they only see the resources you provision to them in that VDC, and they're not aware of anybody else in the infrastructure. They're only aware of that VDC and what they've deployed. And you can have multiple VDCs running on one set of infrastructure or across multiple sites. Very, very unique, because now you can treat every application as a unique instance instead of a shared infrastructure. It's pretty amazing, guys. So that's kind of a deep dive on what the Ignite platform is. And now I'm going to talk about what does that really mean, right? So what does a virtualized network get me, right? I talked about performance benefits. I talk about the advantages and the flexibility we give you. But how hard is it to manage? How hard is it to create one? Well, in the Ignite platform, or in our world, network creation is fill out a form, give me an IP range, a subnet mask, and a default gateway. Pick something like a microservice, so like DHCP. What if you never had to deploy a DHCP server again? Because every virtual network came with one. Well, we do that for you. Same thing with firewalls and load balancers. So you select your microservice, you click submit, and within 30 seconds to a minute, that network is propagated across the switches that Ignite manages. And you're done. Your network is deployed. You don't have to SSH into the consoles of all these switches. You don't have to do commands like show running config, and then config T, let me trunk this VLAN to that port, or multiple VLANs to that port. Let me go to the hypervisor. Let me make sure I configured the LCAP trunk correctly. Let me make sure I'm trunking the same VLANs down. Oh, now I got to go into the VM. I mean, this is really a pain in the ass, guys. I'm sorry about my language, but it really is hard, and it frustrates me. This is why I love Ignite, because we take that pain away. So then what's next? So I have a virtual network running. Well, what do I do next? Well, I want to create a VM or an application. Well, that's easy. You go pick a template. That template could be one that we've imported from a VHD or a VMDK. It could be one of the templates from our global marketplace. It's really up to you. You right-click, you say Create Instance. For everybody, an instance for us is synonymous with a VM. So I create my VM. I specify my memory. I specify the amount of cores I want. I say how much storage I need. I select the virtual network I want that VM to be on. And I click Submit, and I'm done. So again, within 30 to 60 seconds, I got a running application on my infrastructure that's deployed on top of the virtual network. So the last thing that everybody always asks, well, what happens when I need to add more storage to my VM? Well, let's talk about how you do that today, right? If I have a fiber channel environment, I've got to first go to the RAID group or the pool. I got to create a LUN. I got to do LUN masking. Then I got to zone. And then I got to go to the hypervisor, and I got to bring that volume into my data store. Or I got to create a new data store. If I create a new data store, I have to move the VM over to that data store, or I have to go have a VM that has multiple disks from multiple data stores, which makes it hard to manage. Well, with us, it's so freaking easy, guys. You go edit an existing instance. You create a disk. You say how big you want it. You click Save, and within 30 to 60 seconds, the VM automatically detects this storage while the VM's running without a reboot, and he can start utilizing it. He can format that disk, which is a block device presented directly to the VM. It's not sitting across file systems. The other cool thing is, as easily as you add storage, with us you can add more virtual resources like memory and CPU directly to that same virtual machine while it's running without a reboot. That's really unique, because that means I can inject performance and capacity to a running application without rebooting it when I'm having a performance problem. That is innovative. That is different. I don't know anybody else that can do that. So the last thing that I always like to close with is, what does this all mean from a CCO perspective, right? So because we have a single portal that you can see hardware and software in, and we've made it easy to manage and troubleshoot and deal with the daily operation of your environment, you need less people focused on infrastructure, which means more people are focused on applications and meeting what the business needs to grow revenue at the business level. Very, very unique. We actually deliver on focusing resources on the business instead of the infrastructure. That was what was behind the concept of a software-defined data center. But what we found in everybody else's implementation of an SDDC is that you end up introducing more things on top of the physical world, which means I have more layers of complexity that are harder to manage. But with us, you get simple operations and management. Again, it's a single pane of glass, less people, which really means that you don't have to spend so much time on the infrastructure. And you can take that time, which is the equivalent of money, and you can reallocate that time back to the business, because it's a less complex solution that drives a lower TCO. So with that, guys, I know I went quick. If you have any questions, let's talk about them now. Do we have any questions?
If you have questions, just make sure to put it in the chat in the window. So the first question we have is, how does your network virtualization compare to NSX or VXLAN?
Oh, that's an awesome question. I love this question, actually. So when you do NSX today, you're doing what they call layer 2 encapsulation. So I take my 1514-byte packet and I put it in a bigger packet as the payload. And now that packet is 1600 bytes, which means in most worlds, when I send that 1600-byte packet out, it chops it up into 2 packets and transmits it across the wire. Right? So that's CPU overhead to encapsulate and send twice the amount of workload for my original workload. So we don't do that. And now people are starting to use VXLAN offload, which is a hardware ASIC that improves that performance, but there's still a hit. You're still going to lose 10% of your CPU and your network performance when you do NSX with VXLAN. So what we do that's different is a packet is a packet for us. When a packet gets sent, we flip send and receive on that packet, and we put what we call a shadow IP address that we then route that packet through the Ignite platform to wherever it needs to go, and then we flip it back. And we do that in hardware, and it's wire speed. There's no encapsulation. There's no performance penalty. We do it on the switch, so your server resources are not taxed for getting flexibility through a virtualized network. I hope I answered your question. What's the next one, Tessa?
Great. So the next question is, how does your solution compare to other HCI solutions like Nutanix?
That's a really good question. It's funny because we get put into that HCI box all the time because we only take 6U to deploy a fully redundant solution. A fully redundant solution for us is 2 network switches, what we call a compute block that can have up to 8 individual blades that run our hypervisor, and then a storage block that can, again, have up to 32 flash drives of whatever capacity you want. So kind of what Nutanix does is I buy compute blocks in pairs that include storage within. They don't give you a redundant network, and they don't virtualize the network at all. And what that really means is every time I need storage, I've got to buy compute. Every time I buy compute, I've got to buy storage. Well, first, we give you a virtualized network, and it's highly available. Very, very unique. The second thing is, because our compute block is physically and logically separate from the storage block, I can add blades when I need more compute performance without having to worry about storage. That also holds true for the storage. If all I need is IOPS or capacity, I add drives or I add another appliance, It's really up to me. So they scale independently, which means that you get to manage your environment. You get all the flexibility of a converged infrastructure with the integration of a hyper-converged infrastructure. So we really stretch those boundaries and make things easier. Another good question. Tessa, what's the next question?
So the next question is, can I migrate or run my existing apps that are on VMware on Ignite?
Yes, you can. So that's a really good question. So when you think about what that means for us, so if you have your VMDK sitting on a CIFS or NFS server, all we have to do within our UI is you say you want to import an existing template. You point it at that NFS or CIFS store, and we import those VMDKs into our environment in an automatic fashion, and we do our driver injection and our agent load as part of that process, and then it shows up in your local marketplace as a template. And then from that point, you right-click on the template, you say create instance, and you go. Are there any other questions, Tessa?
No, I think you guys definitely add some if you have any more questions at the end, and then I think we'll wrap it up. Oh, wait, we have one more question coming in. How do I get a POC?
That's really easy. So Chris was on earlier, and I heard he keeps these in his car because he loves to do them. But essentially, you talk and he's got a big car, guys. I think it's like the size of a bus or something. He's got like 10 of these or something. But in all reality, you reach out to Chris. He'll coordinate and schedule that POC. He has a partner in crime, Karn. Karn is awesome. He's one of the SCs that works with me every day. And he'll go on site. He'll work with you guys to stand it up. It takes about 30 minutes to get all the infrastructure running. All we need is power and a network connection and an IP range, and you're ready to go.
And awesome. You can reach me through the email address that you can see right now, and also via the phone number on the screen.
Or you could call his personal number. No, I'm kidding.
Forgot to add that on there. Awesome. Well, thank you so much, guys, for joining us. Please make sure to answer the survey at the end of the webinar. It will just pop up on your screen. And we will announce the winner of the drone at the beginning of next week. Thank you so much, guys, for joining us.
Thank you very much.